Hello everyone, my name is Javid and my partner is Qili. Today I'm going to talk about a smart greenhouse. We decided to choose the project because vegetables and crops are demanded in Canada and most greenhouse buildings are far from city or not accessible by farmers. So based off the temperature in Canada, we decided to design the system that measures the humidity and temperature of greenhouse environment to show the information on the screen. Let's look at the detail that how this system help the farmer to save money, time and having easier operation. We use the temperature sensor to measure the temperature. So if the temperature is more than desired operator temperature, the fan will be turned on. In this system, we will use the light instead of that. Humidity sensor will measure the humidity in the soil or environment. If it's less than our desired humidity, the water pump will be turned on to provide water for the crops. In this prototype, we will use the light instead of water pump. In addition, temperature, humidity information and the status of fan will show on the display to make the operation easily. In conclusion, we use less water, electricity and labor to produce more crops that help us to save our budget. If we look at the strengths of the system, we will save time and resources, and it's cheap. On the other hand, the weakness of the system could be including the electricity safety problem and system need the maintenance. About the opportunities, I can say that increasing the products and save the resources such as electricity and water. In fact, the threats is a part of any system. For example, in our system, all components are based on electricity, so failure on electricity causes to turn off the system. But if the customer want, they could use the UPS or diesel generator to supply the energy in temporary situation. Regarding the specification and cost, Arduino IC is the heart of our system that use its programmer to transfer the C language code in it. We use the humidity and temperature sensor to measure the humidity and temperature. We use 2 LED and 1 LCD for the output. And our power supply is 9-volt battery. We use the battery holder to keep the battery, and based on the Amazon and Digit website, the total cost is estimated around $76. Also, we need a bit more budget for building the prototype, such as glue, wire, and paper boxes. Let's look at the schedule. We will purchasing the component before week 4. In week 5 and 6, programming the system will be completed. In week 6 and 7, building the first circuit. And before week 10, we will complete the prototype. And lastly, we try to work on the presentation. There is some website that we use as a references. And thank you for your attention.